Greetings, everybody. This is my second attempt for a homework video, but this one I believe is going to be the one that goes through. So first and foremost, I do want to talk about the fact that the homework, it originally was going to be due this Friday, but I said with all the weather and everything, and I want students to be able to come to me with questions and give you all time also to reach out. So that's why I'm saying the homework will be due next Friday, January 31st, 2025. Now, I do have some notes here that students will be allowed to work on their homework, like in center time. I do give them a few time to chop it off. That way they can see, because mainly the goal of this is study material, getting used to the strategies. That way, when they do see problems that are similar, they know exactly what to do. So it's just getting them comfortable. The next thing is that some of the questions we'll go over in class, or similar questions that are so similar, they'll know the strategy by heart. And also there's a YouTube video that I'm making, which is actually this video right here, which is a walkthrough of the homework. And also the link is going to be posted where you see that light, that aquamarinish blue, that you just click that link, because I'll send the link to this Google PowerPoint to you guys, the homework. So that way, even if the student does lose their homework packet, they at least will have the opportunity to see it on their phone or your phone or something, or their computer, and be able to still work out their problems on a sheet of paper and turn it in. Now, I do want to enforce this, that when they do see the homework test quiz, either on Mastery Connect or on a Bookit or on a Gym Kit, it won't be the exact same questions, because again, I would have already given the answers we're walking through. The main thing is gathering strategies, and they'll be able to use their notes. Their homework will be considered their notes, and it's still counted for a grade. So when they get that additional grade of the test of the homework, they'll know exactly what to do. So I'm just diving in. The first thing this week, or at least what we're going to be talking about next, is 4.NF.3. And if you were to type exactly this standard right here, hold up. If you were to go to type it up, 4.NF.3, on YouTube, you can actually, there's like thousands of videos on this standard from several teachers over the years that talks about 4.NF.3, which is talking about adding and subtracting mixed numbers. I'm just giving you an example of a mixed number. And fractions as well. So this is just a different example. It's all about adding and subtracting fractions and mixed numbers. Now I'll show you some examples. When they see simple stuff like this, they usually do so well it blows their mind. Because it's just basic math skills. Now, one thing in fourth grade, when they're adding and subtracting, they're going to be using like terms, like fractions. And with like fractions, that means that they are going to have the same denominator. I need to thin this out because this is too thick. Okay. So, like I said, with like fractions, and the opposite of this is unlike fractions. And when they get older, like in algebra or something like that, they'll hear the word like terms and unlike terms. And so if anything's alike, that means something, they have the same, right? And if they're unlike, it's just the opposite. They are different. Now with fractions, this means the denominators are different. So in fourth grade, they're going to have to add and subtract mixed numbers and fractions that have the same denominator. But in fifth grade, that's where it might get tricky if they don't understand equivalent fractions and how to compare fractions, because they'll have to use different denominators. This thing is huge. Okay. So now let me go ahead and I'll give you an example. Okay. I don't know. Okay. Well, back to my pen. I'll say 4/17 plus 5 17ths. Again, they both have the same denominator of 17, so therefore this is a like fraction. Now in 5th grade, they'll see something like 5/9 plus 2/10. And there, again, these are unlike fractions because the denominator is not the same. So they'll have to go the extra mile to make this both equal the same thing. And so, like I said, that could be quite tricky for them. And so, multiply the bottom. And this is just a quick way that they could do. And there's other ways. There's another way. So we need to figure out what our whole fraction is that we're going to do. And let's see, 90. So and then they would go from there. But you see how they're going to have to go the extra step and make those things have the same denominator. So anyway, I want to dive right into this basically, and I'm just going to show you a couple of these because this, and maybe even one, because this is very simple. This is solve 4/8 plus 2/8. Now the answer is going to have the same denominator. It has to. So whatever the denominator is, it's going to stay the exact same because it has to be a like fraction. So it's saying 4/8 plus 2/8. Now the denominator will stay the same because we're all talking about the same parts, and then we just do the numerators, and 4 plus 2 is 6. If you're subtracting, it's the same strategy, except you're just making the answer smaller. So you do these two just like that. Now I will show you number 5 because that might throw a student off. So for question 5, it says 3/8 plus 3/8 plus 3. This is dealing with composing a fraction because it's been decomposed, broken down. So we need to just add it up, put it all together. The denominator will stay the same. Now 3 plus 3 plus 3 is the same as saying 3 times 3, which is 9. But we can't leave it like that because it is an improper fraction because the numerator is bigger and the denominator is smaller. And it has to be a proper fraction with the numerator being smaller and the denominator being bigger. So now we have to simplify it out and turn it into a mixed number, which is this form's equivalent fraction. So the way we do that is to do a long division, which divide, multiply, subtract, bring down. And we're going to have to bring it back because it's just one number. So 8 can fit in 9 one time. 8 times 1 is 8. Then I subtract 9 minus 8 is 1. So I have 1 with a remainder of 1. Now my denominator is going to stay the same. It can fit in a total of 1 complete time. And I had 1 left over. So your remainder will always be your numerator. The amount of times it can fit in is always, the whole, and the denominator will be the same. And I'll do question 10 because that'll be done just like that. Again, they all have 8. That's the same as saying 3 times 5, which is 15. Again, I can't leave it like this. 8 can only fit in one time because 16 is too big. So the answer is 1 7/8. Now, word problems also may throw students off, but anytime they see a word problem, they got to use the case strategy and just pay attention for whatever key words, key numbers, whatever they can find. See if the question is truly asking them what strategy they need to use and what they need to eliminate. And they need to use process of elimination. But in this case, I just want you to solve it and get used to it before we worry about that. So I can see here, and I'm going to make this smaller because this is just way too big. It says Gwen ate 2 8s. Danny ate 2 8s. Together, how much pie did they eat? So together is a key word for addition. So basically 3 8s plus 2 8s is equal. And you do it the same way we did these over here. And see, now I want to talk about regrouping. Now I'll just show you this one. 8's pretty easy, so we're going to do 8 real quick. Anytime you're adding a mixed number, you just stack it up. And there's a strategy that we always use. Whole to whole, fraction to fraction. The denominator is going to stay the same. So you can only add your whole numbers to each other, and you can only add your fractions. I can't add this 1 to that 2 eighths, and I can't add that 5 to that 4 eighths, because they're not with each other. So 5 plus 1 is 6, and the denominator still stays the same, and 2 plus 4 is also 6. Now I can actually make this fraction smaller by dividing it by the greatest common factor, and they both have 2 in common. And so the whole fraction I would have to divide by is 2 over 2. And so 6 divided by 2 is 3. 8 divided by 2 is 4. And so the answer is really 6 3/4. So now I will talk about question 9 before I do the word problem. So I want you to get used to the fact that we're going to have to regroup fractions and when they're subtracted. And regrouping always throws my students off for some reason. And not all of them, I'm just saying. But and even when I was in school, regrouping just has a little extra thinking. So it even threw me off sometimes. So basically, anytime you're regrouping, back when I was a kid, we called it borrow. Regrouping is the same thing. Now, the thing with regrouping is very similar to where, in this case, it says solve 8 and 1/8 minus 5 and 2/8. So 8, the bigger number always needs to go on top, and 8's bigger than 5. Now, if I look very closely here, I can very well subtract 8 from 5. That's not the problem. The red flag that comes in anytime you see the problem is the fact that the fraction is usually what gives that away, because we're going to put the bigger whole number on top anyway. So the fraction is what causes the red flag. And as you see here, 1 is actually smaller than 2. So I can't subtract 1 from 2. So that means that I will have to regroup. This is the same way as if I said, I'll just say 81 minus 52. Well, I can do 8 minus 5, but the big problem is 1 and 2. So then you're going to have to regroup. And I would have to take from the larger number. Anytime you regroup, you take from the larger number. And that 8 becomes a 7. Now, with whole numbers, you're borrowing a 10. So it's like you take a 10. So 1 will take that 10 from 8 and add it to himself and make himself 11. And then 11 minus 2 is going to be 9. And then 7 minus 5 is going to be 2. Now, with fractions and whole numbers, we're doing something different. We're not borrowing a 10. We're borrowing a whole. And the whole number, we would use a whole fraction. A whole fraction has the same number on top and bottom. And remember, the denominator has to stay the same. So basically, this 8 had 8 eighths plus. Basically, it had 1, 2, 3, 4, 5, 6, 7, 8. 8 eighths. They had 8 sets of wholes. Now, when we borrowed, it's like they took that one. So 1's going to take one of the whole fractions. It had 8. Now it does not. And it only has 7. And it's going to take that and add it to itself. Just like how the whole numbers take a 10 and add it to themselves. Well, fractions take a whole fraction and add that to themselves. So instead, they took that 8, added it, and so the denominator stays the same, but 1 plus 8 is 9. And now I can subtract because 9 minus 2 is going to be 7. My denominator stays the same, and I can go ahead and subtract my wholes. 7 minus 5 is 2. So the answer is 2 7/8. Now that is a lot of, and you can pause this video and write the scratch work and stuff like that. But it's a lot of explaining, but once you get used to it, it just becomes a rhythm of how you borrow and just add it to yourself. And anytime you're borrowing with fractions, you're borrowing wholes. So the word problem will be done the same way. And you're still going to have to borrow. And the reason why I know that is because, let's look at here. It says Mike walks 3 1/3 miles every morning, while his brother walks 2 2/3. So how many more miles does Mike walk than his brother? Well, in this case, the keyword how many more tells me exactly that I am going to be subtracting. And specifically, I'm going to be subtracting Mike's, and he has the bigger amount, and his brother, Dennis, walked 2 2/3. And like I said, we can subtract the wholes because 3 minus 2, there's no problem there. And this would be the problem. In fact, on the state test, they love questions like this. They love regrouping whole numbers, mixed numbers, stuff like that. And they also like word problems with that. So I can almost promise you it's going to show up on Master Connect. It's going to also show up on the state test. And that is a promise. So I definitely want you to understand and get used to it. Now again, we're going to have to regroup because of that red flag. Again, this is really 3/3 plus 3/3 plus 3/3. These are still 3 wholes, and you know all whole fractions are equal to 1 because 3 divided by 3 is 1. So it's like saying 1 plus 1 plus 1, which is still equal to 3. So we can very well borrow. Now what's going to happen is 1 is going to borrow a 10. Not a 10, a whole fraction. That 3 is going to become a 2, and 1's going to add it to himself. And you should end up with an improper fraction. 1 plus 3 is 4. And now we can go ahead and subtract. 2 minus 2, they cancel each other out. So I don't have to write anything. The 4 minus 2 is 2, and my denominator stays the same. So the answer here is just 2/3. And this scratch work is what goes right here. And that's what goes right there. Alright, so we'll talk more about that. These are just a run through because we have time to master this skill before their next test. Let's go ahead and talk about the study guide for their test coming up. So the first thing, this is dealing with a pattern here. Sandrick and Sandrin's math teacher told them each to create an input-output table following the rule multiply by 7. Sandrick and Sandrin both made tables. Who do you think did it correctly? Now, if I look carefully with patterns, anytime you see the word rule, you already know you're dealing with the standards that's talking about a pattern, and that specifically is 4.08.5. Now, they have to follow that rule, and they cannot break it. And the rule specifically is only multiplying by 7, and you can use your dump your brain for that. Now, we need to see their 2 brothers who got it right. So, let's look at the answer choices real quickly so I know what we're looking for. And I'm going to make this a bit darker. I can see A saying that Sandrick is correct. B saying Sandrin. Now, let's see which brother is correct so we can quickly eliminate something. Let's look here. This is Sandrick's table. So, they have to multiply by 7. Think about this. Is 2 times 7 equal to 14? If this is true, and this is because, right, 2 times 7 is 14. 4 times 7 is 28, and 6 times 7 is 42. So he did right. He followed the rule to the T. But let's look at his brother. We see 14. Now, if he were to even get confused and divide, because think about this though. Anytime you multiply, your number will end up getting bigger. But if you divide, your number will end up getting smaller. Think about it. He had 2, he grew to 14. He had 4, he grew to 28. Now, his brother started with 14 and he dropped to 7. So he ended up getting smaller. So we know he's not even multiplying, he's dividing. And on top of that, 14 divided by 7 is not even 7, it's 2. And then the rest of these, he still did them wrong because he's supposed to multiply by 7, not divide. So now we know that Sundrin is incorrect and his brother is correct. So wherever I see Sundrin, I know that he's wrong. So if they say he's correct, I'm going to cross him out. So D and B are both wrong because they're saying Sundrin is correct. Now we know Sundrick. Let's see why he's correct. A says he is correct because he's dividing 7. No, they didn't ask us to divide. He did right because he multiplied 7. Alright, so again, see how you have to pay close attention to the answer choices. And once you can pay attention, it's actually pretty easy as if you know what to eliminate and what not to eliminate. Let's go to the next problem. Alright, Megan wants to teach her main cat about how input and output tables can be used with patterns. She decided to make a table with an input represented by an X and an output represented by Y. And they're going to see X and Y a whole lot when they get older in math. So this is probably why it's being introduced in 4th grade. Alright, so which number completes the table? And her equation that she's using is y equals x plus 7. That's really the rule. This is the same thing. It's just put in a different form when it says sundry and it was multiplying by 7. Well, in this case, their rule is whatever it is, you're going to add 7. Because if you pay attention, 9 plus 7 is equal to 16. And 13 plus 7 is equal to 20. Now, they don't know what's here. But you can actually do the inverse operation and actually subtract by 7. And so 7 minus 7 is 0, and then 2, you bring it down. And so the answer is 20. 20 does fit the rule because 20 plus 7 is equal to 27. The rest of these, you can add 7 to equal 27. Alright, so let's see this one. This is more patterns here. So, Tarzan and Jane started a restaurant in the jungle. They call it the Tree House Paradise. They have different parties of guests coming in, and they decided to put it in a table. By looking at the table, what's the rule? Now, again, we see a key phrase here, the rule. We have to pay attention to that so we can see. So we're going to look at the pattern and see if we can predict the rule. Now, this side is just for organization, so we really don't need this. But I can see they started out with 3. Then it actually jumped up to 10. And it just continually got bigger. So we already know out of each operation that there is, we know 3 times nothing is going to give me 10. So we're not multiplying. I know the numbers are getting bigger, so we're not subtracting or dividing. So the only thing is left is adding. The question now is how much are you adding by? 3 plus 7 actually gives me 10. And I also see that 24 plus 7 is going to give me 31. So I can see my rule already, and it's simply add 7. So we look at the answer choices. A says add 7, B says add 9, C says double the number. That means to multiply by 2. I already know 3 times 2 is 6, not 10. Add the parties together. They said nothing about 3 plus 45, and how's that going to give us the answer? No, that has nothing to do with the rule. And again, we're not adding 9. We're specifically adding 7. Alright, now we're going to talk about equivalent fractions. And all equivalent fractions, they're equal. So if I said 1/2 and 3/6, they're the exact same thing. Now, a help for this, I want you to understand equivalent fractions can get bigger. And if they're going to get bigger, you're going to have to multiply by a whole fraction with the same number on top and bottom. And if I were to multiply 1 times 3, that gives me 3. 2 times 3 is 6. So this is still equal. And if you were to show this way as well, if you were to cross multiply, they are equal. Now, to make an equivalent fraction smaller, you have to divide by a whole fraction with the same number on top and bottom. So, and you are going to divide them by whatever the greatest common factor is. And if you don't know the greatest common factor, you can use a T-chart and write their factors. And I can see they both have 5 in common, so that means I can divide them both by 5 and end up getting 1/2. So you see, when you want to make this smaller, you're going to divide. If you want to make one bigger, you have to multiply. So let's talk about this. The easiest way to do this instead of the cross multiplying is making an equivalent fraction, shrinking it. Because look down here. It says draw a line connecting a fraction with its equivalent fraction model. So in fraction models, you're going to have to literally write the total. And I see this as a total of 6 parts. Now, I did this so students can kind of quickly assess and get an understanding. But if they're on a test, they're not going to have it counted for them. They're going to have to literally count each block and write the total, which is their denominator. And your shaded is your numerator, or whatever they're asking you for. So if they're asking me the amount shaded, it would be 4. But if they're asking me for the amount unshaded, it would end up being 2/6. But in this case, we're just doing the shaded. And now the best way, I can see all these fractions up here are actually smaller, which means I'm going to have to divide these down here by a whole fraction to make them equal. So I need to see their greatest common factor. If I were to look at 4 and 6 and put them on T-charts, I can see 1 times 4, 2 times 2, 1 times 6, 2 times 3. They both can use 2. I can't use 3 for 4 because it's not on here. I can't use 4 for 6 because it's not on here. So I know the whole fraction I will divide by, divided by 2 over 2. And I'm going to end up getting 2 divided by 4. And then you just divide straight across. 4 divided by 2 is 2. And that's a 3. So this is equal to 2/3. So that is equal here. Okay. I know they both have 4 in common. And this is equal to 1/2. They both have 3. This is going to be equal to 1/3. And then 5 over 5. And this is equal, also equal to 1/3. So there, that will be our answer. So 2 of these were equal to 1/3. Alright, so now I'm going to dive right into this right here. And again, we're talking about patterns here and the rule. So what are they basing it off of? That's your rule. And I see it went to 4. So, and if you think about it, 1 plus 3 is 4. 4 plus 3 is 7. So I can see they're repeatedly adding 3. Now, they're not adding 3, then adding 1. They're not doing 2 things. They're only doing 1. And we're definitely not adding 4. So the only thing is just add 3. Which pattern follows a rule? Again, now specifically, they have two things. Add 10, then subtract 2. So the first thing they're doing is adding 10. So let's look and see if they added 10 first. So I can see 5 plus 10. So this does. But the next thing they have to do is subtract. And subtract means the number is going to have to get smaller. So I can see C and D, they both grew and got bigger. So they added something. Now, think about this. Subtract 2. 15 minus 2 is actually 13, not 8. This one, what is the area? Now, this looks very weird because students are used to seeing A equals link times with. Now, they probably won't see something like this on their state test, but Master Connect does like to throw things like this. Nonetheless, I'm going to go over something similar. So basically their rule for this is 1 square is equal to 1, basically. So the triangles, you can't count them as one. You have to count them both together because actually a square is like putting 2 triangles together. So 2 triangles equal 1 square. So let's count 1. And the area means the inside, not the outside. So 1, 2, and then this will be 3, and that will be 4. Now, which fraction is greater than 1? Here's something you need to know. All improper fractions are always greater than 1. Second thing, all whole fractions are always equal to 1. And the last thing, all proper fractions are less than 1. So let me break it down and prove it to you. If we said 8 divided by 4, because all fractions are division problems. 8 divided by 4 is equal to 2. And 2 is bigger than 1. 8 divided by 8 is actually equal to 1. And 1 is equal to 1. And if you think about half of a dollar, just think about half of a dollar. $1. Half of that is 50 cents. And 50 cents is less than a whole dollar. So, again, all improper fractions with the numerator is bigger and the denominator smaller, it's going to be greater than 1. If you think about whole fractions with the same number on top and bottom, equal to 1. And a proper fraction with the numerator is smaller and the denominator is bigger, it's going to be less than 1. So they said which is greater, and the only answer here is 6/5 because this is equal to 1. These are both less than 1. And 6/5, if you were to divide it and turn it into a mixed number, the answer is going to be 1 1/5. So it's 1 with extra left over. That's still greater than 1. Now let's look at this one. Appa Aang cut a giant pizza into 12 equal pieces for Appa and Momo to eat. Appa ate 9 pieces while Momo ate 1 piece. What fraction of pizza is left? Now here's another key word that you also need to pay attention to. What's left? They're not asking you for the amount eaten, because I know that they said Appa ate 10, no, he ate 9, and Momo ate that, so they only got 2 left over. So the amount that's left is equivalent, it's 2 12s, right? Now, just imagine you didn't have a fraction model to visualize this with. You would have to do, they started with 12 out of 12, right? Because he said he had 12 equal pieces. And then Appa and Momo ended up together eating 10 12s. And then they ended up being left with 2 12s. Now, we can do process of elimination because we need a fraction that's actually equivalent. And sometimes they won't tell you that. You just have to know by looking at the answer choices. You need something that's going to be equal. Now, you could compare them all Or you can do some eliminating and save yourself the time. So what I'm going to do is look very close, because I know I have a numerator of 2 and a denominator of 12. Think about this. Can 9 ever multiply to make 12? No. And 3 can't even divide to make 2. Now, can 6 can actually multiply and make 12, but can 2 multiply and make 5? No. 2 can make 4, it can't make 5. So do you see how I just eliminated just by looking at what can't even match in that dump your brain for that group? Because if you were to use your dump your brain and put your finger on the numerator and the denominator and drag your finger across, you'd see what would be equal. So now I just look at thirds. Let's divide 2 12s first. I could actually simplify it and make it 1/6. And I can't make 2/3. I can divide 12 by 4, but I can't divide 2 by 4, so 2 can't stay the same anyway. But if you were to do it another way, 3 times 2 is 6, and 2 times 12 is 24. Again, that's not equal. And 1 times 2 is 6 times 2 is 12, and 1 times, so this is equal. And we can see here, this actually is the same thing. So there are 2 methods you can use. Actually 3, because you can use your dump your brain, you can do the cross multiplication, or you can use the divide by a whole fraction and make them the same. Alright, so let's see, is there anything I missed? Nope. Now let's go ahead and dive right in to do some rounding. Anytime you see some keywords, I see a keyword estimate here, closest, those are words for rounding. And again, you have to underline around the place, box a digit to the right, 5 or more, round up, 4 less, let it rest. And don't forget, anytime you let it rest, it's like you're carrying a 0. So if I said 51 and I'm underlining the rounding place, you can't round a 1's place anyway. So you box that digit, and that 1 is going to round down. Anytime you round down, it's like you carry a 0, because that number is going to stay the same. And 0 plus 5 is 5, and everything after the rounding place will turn into 0. But on the contrary, if anytime you round up, it's almost like you carry a 1. And 1 plus 5 is 6, and anything after the rounding place will turn into a 0. So anytime you round up, you carry 1. Anytime you round down, you carry a 0. So they want to know what's the closest estimate of all 5. That means they want you to add this up. So if I look here, the best thing you can do is round it up first to the farthest place, then get your total after you round it.
What I believe.
1 second.
God is chasing every one of us.
Okay. I don't know why TVs have a mind of their own. Now, let's see here. That's going to round down because of the 1. Remember, 5 or more round up. But if it's 4 or less than that, it's going to round down. So this will be 20, 20, 30, 10, 10. 10 plus 10 is 20. 20 plus 20 is 40. I got to add the 30 up in there. 40 plus 30 is 70. And 70 plus 20 is going to be 90. Okay. I'm writing on my Samsung tablet. Alright, so let's read this question. It's an area and perimeter question. Azula is making another war balloon, yet this time she is using a regular hexagon shaped wooden plank. So here's another key word. They told us the shape she's using. Now, your scholar may not always see the shape themselves. They're going to have to actually imagine it and think about keywords. So, a regular hexagon. Each side is 7 feet long. What is the perimeter? So now we actually are able to get down to the nitty gritty because we have everything we need. The word hex Hex actually means 6. And I know each, most of the time, means multiply. Sometimes it can mean divide, but in this case, it's going to be multiplication. And 7. So you could do a shortcut, 6 times 7. Or you can think about this. You got 7 plus 7 plus 7 plus 7 plus 7 plus 7. Either way, you already know the perimeter is going to be equal to 42. And you need to know your prefixes. Anytime you're dealing with shapes, prefixes will give you the answer. Remember, like triangle means 3, pent means 5, quad means 4, and hex means 6. And oct means 8, but I didn't put that there. Alright, so, again, this time Azula's still making a war balloon, but in this time, she's going to have, her size is different. It's 5 feet long. And again, she's using a regular hexagon, and hex means 6. And so I already know 6 times 5 is going to be equal to 30. Now, Zuko is training Aang to shoot a giant fire rocket from his hands in 2,145 seconds. What is the amount of time rounded to the nearest 10? So again, we're rounding, and not only that, to the nearest 10. So we got ones, tens, hundreds, thousands. They said round to the nearest 10, so I need to underline my tens place. And I can see that 5 will actually make it round up. And it's like I carry a 1, so anything before it stays the same. 1 plus 4 is 5, and everything after it turns into a 0. Again, anytime you're dealing with comparison, just know the alligator mouth will eat the bigger number. Now, I do want you to remember the difference, because sometimes you'll see a word form. And so you need to know that these two symbols, greater than and less than, they're like fraternal twins. Okay, so I want you to think about this. If you think about the word out of greater than and less than, L is facing this way. So if the alligator mouth is opening up towards this way, that means, just like an L, it opens up in the same direction. So listen, it's going to be facing the same way as an L. See how they both open up to the same direction. And if it's facing this way, it is going to be greater. Now, the alligator mouth will always eat the bigger number. So I'm going to do a solid here and look at to see which sentence is true. That means that there's all 3 lies and 1 true. Alright, I can see 4 is actually less than 5 is actually less. This is actually true. And 5 is actually greater. So there's only one that was right. And the only thing that was right was C. Now, we're talking about some fraction bars, but since they already have the fractions down here for us, all I gotta do is just pay attention to this down here. And we're not adding anything because we're comparing, so we're not gonna do this. And again, I know these aren't equal because think about it. 4 and 5, they can't meet on a dump your brain. And 4 and 3 can't meet on a dump your brain either. So now we're just going to compare to see which is true. A is saying 4/5 is less than 3/4, and D is saying 4/5 is greater. Let's see which is right. Ding, ding, ding. We have our answer. 4/5 is greater. So that means that A is wrong, D is right. Remember, the alligator mouth eats the bigger number. In this case, this produced the bigger side. Let's see here. Okay, now let's look at this. Team Avatar is being chased by Azula and the Dai Li. They are going to end up in a dead end in a cave. They know if they don't find a perimeter, and I don't know why I printed like this. If they don't find a perimeter, Azula and the Dai Li would enclose. And enclose actually means surround. Enclose them and capture them. Help them find the number of feet Azula and the Dai Li would need to enclose them in the dead end. How many feet would it be? Study the figure and its length and its width to find out. So anytime we're dealing with enclose, that means surround. That's going to be dealing with the perimeter, because it's talking about around it. Area is talking about the inside. So we don't need A equals length times width, because we're not talking about area. But we do know we need the perimeter for rectangles. P equal to L plus 2W. Or you can say side 1 plus side 2 plus side 3 plus side 4. But it's just so much easier if you know it. Now, 2 times the length plus 2 times the width. 2 times 12 is 24. 2 times 5 is 10. Well, 24 plus 10 is going to be equal to 34. They wanted you to think this would have been the area, but we weren't looking for the area. And again, these are just something they just had for you to try to trick you with. Now, let's talk about another comparison. Sokka and Aang were eating some candy bars. After eating their candy bars, what do they have left? Alright, so which number sentence correctly compares to chocolate? So here, I see their bars, but again, we really don't have to worry about this, because they already have the comparisons here for us to see what's right and what's wrong. So, now let's see here. Let's just compare and see what's true and what's not. Alright, so I see twice they're doing, and you can even use your dump your brain. I can look here and I can see 1/2 and actually 3/6. If you know your dump your brain, that's actually the same thing. Because if you were to multiply by 3 times 3, 3 over 3, you end up getting that. But let's just show this here. 2 times 3 is 6. These are actually equal. Now let's check 1/2. And before we even do that, 3 can make 12. 8 can make 1. But here's the thing. Can they both be divided and end up getting those numbers? So if I were to simplify 8 12s, I can divide them both and only by 4. Because I can use 4 to multiply and get 8. And I can also use it for 12. And I will end up getting 2/3. Not 1/3. And if you were to check and put your finger on 1 and 3 and scroll and try to get to an 8, you're not going to see them together like that. So we also now we're just left with comparing 1/2 and 5 6. And you can also just cross multiply them all and see from there. But 2 times 5 is 10 and 6 times 1 is 6. Now 5 6 is actually greater than 1/2, not less. Now we're going to talk about a pattern here. They're going to show you a rule without telling you it's the rule. Katara has 279 gallons of water. Every week she will use 9 gallons. Which number pattern shows how many gallons will be left each week? The word will be left is a subtraction keyword, and in fact use is subtraction, and not only that, she uses 9. So my strategy for this is just, instead of seeing each one, you can just write it out directly. She started out with 279, right? Then she will subtract 9, because that's her rule. And it's going to be So this is the first thing. This is the next thing. Then she's going to subtract 9 again. Okay, and so I see they only got 1, 2, 3, 4, 5. So 2. We're good. So the first thing I see, it was 279. After that, we ended up getting 270, and after that, we ended up getting 261, and then we ended up getting 252. So if I look here, I already know we should have had 270. C and D went to 275. That's not subtracting 9. After that, they both, A and B, have the right sequence, but we got two differences here and here. And I already know after subtracting, we ended up with 252, not 251. Okay, we're actually almost done with this homework. This is the last question here. Alright, so if I look here, it says Team Avatar started out with three dozen Fire Nation soldiers to take down. They took down 2 dozen soldiers the first day. The next day, they took down 9. The remaining soldiers retreated and ran to their camp. What is a way Team Avatar can find out how many soldiers escaped? Now, if you don't know any better, or if you do, this is just in general, a dozen actually means 12. So you just take the number dozen they have and multiply. For instance, they said they had 3 dozen. That's the same as saying 12 times 3, which is 36. So they started out with 3 dozen, which is 36. After that, they ended up defeating 2 dozen, and 2 dozen, that's 2 times 12, which is equal to 24. So they took down 24. That means they have less now. That's, again, subtracting. And then they took some more down, so they ended up taking down 9. Again, I'm still subtracting. Now the rest, whatever was left, they ran and escaped. And they want to know, what did they do? What is the equation that is shown here? Now, let's look. A says add, B says add, C says subtract, D says subtract. Were we adding at all? No. Now, think about this. Did we start out with 36 or 39? And we already know we're doing 12, and 12 times nothing gives me 39. So the only answer was subtract 9 from 36 and 24. And so really, they ended up having 3 left. Alright, so this other page is just, if you have any questions, you can write it down. Sometimes I'm like this. If I could have a question at the moment, something I just don't get, and then when I get to class, I completely forget about that question. So if you have any questions, write it down. If you have questions about improper fractions, you might say, what are they? Or whatever the case may be. Any questions you have, concerns or anything, you can write it down. But please remember to do the easy questions first, hard ones last. And the medium questions in the middle or whatever. Show your scratch work. That is absolutely mandatory. And that's what this homework is, your scratch work. That's counting as a whole separate grade. So, again, I hope this helps. Please reach out. Do not hesitate if you're a scholar, or if you are the scholar watching. If your homework, something happened to it, don't wait till the last minute. I don't want you to wait until next Friday. I don't want you to wait. If you're in class and you're either you lost it or you missed it or something, or have any questions, please ask beforehand. Again, I will be sending this link out for the video, and if you want to find it, go straight here and just click it when I send it on the school status or through a text message. And I also want you to just be aware that I'm going to send this PowerPoint itself in a link to your phone. So if you need it bigger or something, you can clearly see it on your phone. or just having it just in case you lose your homework. You can either watch the video and still get the questions and work it out in scratch worksheet of paper and turn it in, so you still get credit. And again, please pay attention to the strategies. Do not let this video go to waste. I spent almost an hour breaking down everything, so please don't let my work and care be for nothing. Thank you, and thanks for being a wonderful scholar watching this video. Please subscribe, because I make a lot of math videos now, and when you subscribe, it'll just notify you when something comes up, and if you need to watch it. Thank you, and have a blessed day.